There may be cases when you have digital outcrop data or any kind of structure from motion data that doesn't have georeferencing. And in this tutorial, I'm going to show you how to use some publicly available elevation data as a basis for georeferencing a high-resolution structure from motion model. So we're going to start off with a completely new project. And I'm going to call this one New Mills after the location. Once the project has started, just have to wait for it to generate the project. I then go to data, and I'm going to import a point cloud. And for this one, it's a .asc. It's in my input data file here. I've actually got two versions of the same data set here, a digital surface model and a digital terrain model. I'm going to bring in the surface model, so that will still have the buildings in it. So there's our surface model. You can see that's come in as a point cloud. While I'm here, let's import a bitmap. I'm just going to pull in the overview bitmap. So this bitmap comes from the Ordnance Survey. It's an overview of the entire UK. So we can see where our data set lies. And to start with, I shall mesh or triangulate this model. So in VRGS, I go to Operations, Triangulate, maximum edge length. This is a 1 meter data spacing in map view. So that means when you've got steep-sided surfaces, the actual data spacing, the distance between the points, is much greater. So I'm just going to put a very high value in here. And then it's set to triangulate from above, and everything else can be left the same. But we can get rid of post-optimization because it's irregular data. This mesh will already be quite optimal. And then we just have to give it a few minutes for this meshing to run. It will appear under your triangulated meshes, and it's running at the moment. So this data comes from the Environment Agency. It's LiDAR based data and covers pretty much the whole of the UK at a 1 meter data spacing. And there's a variety of ways that you can get that data. And we'll just leave this to run for a bit, and we'll pause the video and then restart after triangulation is finished. It's going to take a few minutes. The triangulation is finished. While it was triangulating, I've also imported, using exactly the same process as I've just shown you, the terrain model version of the same elevation data. So we've got the surface model and the terrain model now, and I've meshed that in exactly the same way. I'll switch off the point cloud. Here's the surface model. There you go, it's a nice triangulated mesh now. And in the surface model we can see the houses and the trees. If I switch to the terrain model, see the terrain model is processed and the trees and the buildings have also been removed. However, you'll also notice that the bridges have been removed in this as well, and we might want to use those as a assistance in our georeferencing, as you'll see later on. Okay, with the elevation data, I can go to texture map, import texture map, and import the texture map for this particular. Will take a moment or two to load. As it's loading, it has to compress the data. It's compressing the texture, which is a one-pass process. And there we've got our terrain model, and I'll just do the same for the elevation for the surface model. So we go import texture map and it's exactly the same texture. Referencing information if it's a geotiff or if there is a world file associated with the texture, the georeferencing information will come from that. Right, we've got our textured elevation data. The next thing is to import our structure from motion data. To import your structure from motion data, find your directory where you have your OBJ file, as I'm using in this case, and simply drag and drop your OBJ file into the 3D view, and you'll see that it starts to import that data. When you have the OBJ file in your directory, make sure you've also got the textures and the material file associated with that OBJ file in the same directory. Then we just have to wait a few minutes for this to import. As it's importing, it'll tell you in the Messages tab what stage of the process that the software is in. So it's reading the OBJ file, it's imported the material file, it's currently reading the vertices and the triangles. And once it's finished reading the vertices and the triangles, and if you select the name of the mesh, you can see an update in here on where it is in terms of the number of vertices and triangles that it's read. And from there, it's starting to read in the triangles now. And then it's a case of just waiting for it to process the data. This is quite a large data set, so it's going to take a while. Once it's finished loading the vertices and the triangles, it'll then go on to do some extra processing on the data, and you'll get some extra information appearing here. So just have a bit of patience while it processes. So after a few minutes, the processing of the OBJ file is completed. In the Messages tab, it's told us, given us some feedback on what's happening with the processing, and it's telling us here it's building the BSP tree, the binary space partition tree, which is a way of being able to sort through the data much quicker, and the task is completed and we're done. The OBJ file has now appeared in our data tab, and if I select that, switch it on to display it, nothing's appeared because this is not georeferenced. So I'm going to select go to, and it'll take me to where the model is. So the first time we display a model, it has to compress all the textures, and that's what's going on at the moment. So we just again need to be patient for a minute or two. This is one pass, it doesn't have to do it again once it's done it for the first time. After about a minute, all of the textures have compressed. It depends on how many textures you've got. Down here it tells us in this particular model we've got 4 textures. We're now ready to work on the model, and if I look from above, we can see that this model, and from the side, it's not georeferenced at all. It's in a local coordinate system. It's not even oriented correctly. So we need to try and fix that. If I go back to our surface model, the area that we're looking at, I'm just going to switch off the bounding boxes. The area that we're looking at is over here. And as always the case, our study area isn't nicely in the middle of a tile, it's kind of sitting right on the side. But it's just the way it always seems to be. Anyway, the area that we've got, this is the bridge in our model, and the outcrops around these faces here. My first step is I'm going to put in a waypoint. Now I happen to know that I can see the top of this building, or the end face of this building, in my structure from motion model. So I'm going to go to interpretations, and at the top of that I'm going to place a waypoint. The waypoint will appear in the data tab, and from waypoint, I'll use copy position. I'm then going to go back to my structure from motion model. Don't quite have the type of the building, but that doesn't matter. We just need to get this data into more or less the correct position. Make that mesh active. This is our structure from motion mesh. Go to the extended menu, and I'm going to put a control point in, and in the mesh that will appear under tie points, paste target position. That's assigning the position of our waypoint to this control point, saying that's the target. Correct from the control point. And now when we go back to our surface model, I have to wait a moment or two for the graphics cards to update because we've moved the data, and we should then find, and there we go, there is our outcrop model placed much closer to where we want it. There's three things that we have to correct with this. We need to correct the position, the orientation, and the scale. So I think for the next step I'm going to switch to using, from the surface model, I'm going to use the terrain model instead. You'll see why in a moment. It's much easier just looking on this auto-corrected image to work out what the width of this building is. From interpretations, select measure horizontal, and I'm going to measure a horizontal distance across that building, and that's telling me that building is 9.3 meters wide. So I'll use that information here from the extended menu for the active mesh. Say from there, one side of the building to the other, currently is 3.9, and we want it to be 9.293. Give it a moment to reprocess data, and there we go. We've now got our model rescaled to be hopefully the correct size. The next thing to fix is the orientation. So we need to find things that are likely to be vertical or horizontal. And some examples that we've got is the side of this building is likely to be vertical, and hopefully when the bridge was built, the bricklayers would have probably made these layers of bricks horizontal. So that's what we're going to use as our first reorientation of the data. In interpretations, dip azimuth 3 points. I'm going to measure the orientation of that layer there. And that's given me dipping at 25 degrees towards 155. In my data tab, go to the structure from motion mesh, and it's in operations, transforms, remove a dip. We could type in the values, but to make life a lot easier I can just do get, and it will list all of the orientation measurements that are displayed at the moment. That's the one that we've just recorded, and select OK. Again, give it a moment to reprocess. And there is our bridge, hopefully correctly oriented or flattened, or at least with the horizontal correct, not correctly oriented. To get the orientation properly correct, we need to take a measurement of something, and a good thing to take a measurement from here is the direction of this road, which will be the same as the direction of the side of the bridge. Select a plunge measurement for this one, and take a point from there to a point from there, which is giving me it's in orientations, there's a direction measurement of 4 degrees towards 159. Right. So my next step here is back to the extended mesh menu, and from control point select orientation, where you can plot or draw on a vector, and then we say we want this to be dipping at 4.5 degrees towards 159.2. And we've now got another control point that this time it's got two vectors, one that shows the current orientation of our control vector and the target orientation of the control vector. From corrections in our extended mesh menu, I'll use from orientation for the correction. And there you can see it's now changed that so those orientations match up. So we're getting there with our orientation. We need to fix the position. So for me, in this case, what I'm going to do here is I'll momentarily switch off the terrain model. Back here I put a control point in at that point, and then the waypoint that we want goes on here. That's an interpretation. Put a waypoint, just put it about there. Copy the position of the waypoint, paste it as the target position of the control point. I'll switch the other control points off because we don't want to use those now in the correction, and correct from control points. And there we have it. So let's just have a quick review. Is it looking okay? Well, I think the orientation is out. This side of the bridge looks too high compared to that side. And maybe we're a little bit high as well. Now, as we've gone through various transforms, some of our corrections might not, or might have been modified slightly. So I'm going to go back to the bridge here, back to interpretations. I'm going to put another orientation in on the bricks. If I look at that now, see we're dipping at 5 degrees. So as we've done other transforms, and particularly the correcting the direction, it'll modify the overall tilt of the model as well. Let's correct this one again. So it's back to data, new mills, model, and it's in operations, transforms, remove dip. That's the one. Give it a moment. It'll do and move around that point, and you can see how that's changed the orientation. And when we go back now, we're starting to look a little bit better, closer to what we're expecting. There's a few other things that we can use as checks. We can look at the position of the bridge compared to the position of the projected ortho photograph down onto the ground. That doesn't look too bad. We can also take a look at if there's any height errors, and there does look like we've got a bit of an error in the height as well. We're a little bit too high to do that. So measure vertical. There we go, that's a bit better. Now, so the measure vertical tells me that the vertical distance here is 1.2 meters. So I need to subtract the offset that we've got from this vertical measurement, the 1.2 meters, from our structure from motion model. I'll do that in operations, transforms, translate. And we need to translate by minus 1.21 meters. So translating Z, positive goes up, negative goes down. Get a moment to, and there we've got our elevation data and our structure from motion data tied up quite nicely together. And there we go. So that shows you how you can get a fairly reasonable fit between your structure from motion data and elevation data if you haven't got any georeferencing information at all. We could carry on for a bit longer and do a few more corrections. This is where our surface model is also quite useful, but looking at the surface model as well shows us that that lines up quite nicely with the data as well, giving us a fairly good confidence in the positioning. Now if I look down here, this shows me here that maybe the translation, the horizontal translation, is maybe not quite as good as I thought it might have been to start with. This would be a good place for us to use the waypoint and GCP. So I'm going to just do that. We're going to put a waypoint where we think we want the data to be, and then into the mesh control point. That's probably going to be about there. Copy position, paste target position, and then switch off all of the control points that we're not using, so the corrections will only work on the tie points that are displayed. And then let's see how that's worked. There you go, that's looking quite good. So there is our structure from motion data fairly well georeferenced. And here it is shown with our terrain model. Now the next stage in this process would be to clip out the terrain model. Maybe we need to do a few more corrections and just check the orientations in here again. So quite often you have to iterate through these processes several times. Still got a slight dip. We'll remove that one again. Switch off all the orientations apart from the one that we want to use. Stick that back where it came from. So back in operations, transforms, remove dip, get from that one. Translate it and change the dip slightly. And perhaps we might want to raise this up a little bit as well, just to get everything in the correct position again. So let's check our measure vertical from there to there. 0.88, data, emails, operations, transforms, translate. 0.88. Yeah, there we go. That's looking more like it. So that seems to match up. Fairly good with there. We could maybe tidy that up a little bit. Positionings of these walls look not too bad. Maybe again we could translate those across a little bit. So I'm going to do this manually. I'm going to move. So let's do a measure horizontal. So we've got about 1 meter to move. Along. Well, we're going to move we'll move meter by the x dimension, so x coordinates, so we'll move along that way. Data, emails. This one we want to go operations, transforms, translate, and I'm just going to move it by 1 meter. So there we go. And you can continue tweaking the data until you've got it into a form and a position that you're pleased with. The next step, once we've done this, is to then go and tidy up the elevation model. We can cut holes in the elevation data and then place the, so when we've got the structure from motion model inside the elevation model, we don't get this sort of overlap of the two data sets. So there's our new milled data. We've gone from a completely empty project through to a model that has a fairly good georeference for a structure from motion data set that was just derived from walking along with an SLR camera, taking lots of photographs. No GPS, no georeferencing information, but now we've got it into its proper 3D global position with the correct orientation and scale. If you want to know how to cut a hole in your digital elevation data so that the structure from motion model sits nicely within the data set, then there's a link at the end of the video to show you how to do that.